Okay. Um, so moving on, keep in mind that all this stuff is based on probability. So I talked a bit a while ago about how we never prove anything in psychology. Um, there's just some stuff that gets enough support where pretty it's pretty tough to argue against it, but um, generally we still don't say proof because everything is based on probability. And probability is, of course, prone to error. So sometimes we'll get false positives and sometimes we'll miss actual effects. So there's two different errors you can get when running these stats. So obviously these stats are meant to meant to reveal what's actually a meaningful effect, what actually indicates a population difference, but they're not perfect because obviously they're based on probability. So one scenario is that there's no actual difference in population, in the population. So maybe just hypothetically, this is not true, but maybe cell phones don't distract you while you're driving. So there's no actual difference between cell phone users while driving and non-cell phone users while driving. Well, keep in mind that, again, like we've been talking about, these sample means are going to vary, right? They're not going to come out, or at least it's unlikely that they'll come out exactly the same, right? They're randomly drawn, so they might be bigger or smaller than the true population. Sometimes, and although our tests are meant to evaluate for this, sometimes you end up, again, due to sampling error, with enough of a difference that the test says, yeah, um, this indicates a population difference. Maybe you happen to draw, yeah, this is not true, but just draw a sample where the people using cell phones just make a lot more errors than the other sample where they're not using cell phones. It's not super likely, but it is certainly possible that you just draw sample means that are different enough that you get a false positive. This is also known as a type 1 error. So again, just concluding that the two populations are different when they're really not different. We've got just samples that are different enough due to sampling error to suggest there is a difference. That's a type 1 error. Okay. And of course, in this situation, what should happen is that if there's no actual difference in populations, then we um, should get a non-significant result, right? The other possibility is that there is actually a difference and you don't pick up on it. So let's say you have a difference, kind of looking at this one, or no, not this one actually, but you actually do have a difference in populations. Well, ideally, you should draw two samples that are significantly different, kind of like you see here on the bottom. However, there's also the possibility that you happen to draw samples that are close enough that you don't find a significant difference. So kind of the opposite. There is a difference in the populations, but the samples you draw are too close to each other to pick up that difference. Okay? It's sampling error working against what is actually a population difference. This is known as a type 2 error, or when you miss what is actually a true difference in populations, or actually a true effect. Okay. And of course, in this situation, when there is an effect or a difference in populations, we would want to pick up on that because that would be the accurate outcome. Okay. All right. So if a result is statistically significant at a p less than 0.05, then the probability of making a type 1 or a type 2 error is less than 5%. Which is it though, type 1 or type 2? Think about that for a second. Well, this would be a type 1 error. Why? Well, type 1 error, remember, is that you're getting a false positive. So you're finding a significant difference in means, but there's no actual difference in the populations. You conclude that there are two populations when really the samples came from the same population. So since our p-value is less than 0.05, remember p-value says what are the odds of getting this difference in sample means, assuming there was no actual difference in population means. Well, here, since that p-value is less than 5%, this means that there's less than 5% chance that you found a false positive, that by sampling error, you got a significant difference. By the way, it's kind of hard to tell what's a type 2 error. That's kind of beyond what we're going to go into for now, but it has a lot to do with sample size. But for now, just remember the difference between a type 1 and type 2 error, and remember that your p-value is really just telling you what are the odds of a type 1 error here. All right.